we discuss about the project automatic detection and measurement of structures in fetal health ultrasound volumes using sequential estimation and integrated detection network. Let me discuss about the abstract of the project. Ultrasound measurements in pregnancy involve measurement of fetal head and brain structure manually from 2D ultrasound volumes. This process required more time consuming. So here proposed an automatic fetal head and brain system which measures anatomical structures from 3D ultrasound volumes. The detection relies on sequential estimation technique. This structure processes and results obtained by this method can detect more than objects detected individually. This new model solves many challenges such as speckle noise, signal dropout, shadows caused by bones, and appearance variations caused by the difference in the fetus gestational age. The detection process is done by threshold-based segmentation, which is used to estimate sequentially. With this, our proposed method, the standard visualization plane are automatically detected and measure the value of an anatomy histogram equalization to image because some images have more brightness and some have low. This may cause imperfect segmentation result. In the high contrast image, the low pitch cannot be determined and the segmentation cannot make perfect, and in the low contrast the image, the statistical feature are extracted from the segmented region. Finally, neural network classifier is used for classify the fetal head to their growth and health. Let me discuss about the flow diagram for our process. First, capture the input image from source file by using a getFile and imRead function. User can able to change the size of the image by providing pixel height and width with the help of imResize function. Next, in the hybrid median filter is windowed filter of nonlinear class that easily removes impulse noise while preserving edges. In comparison with the basic version of the median filter, hybrid one has better corner preserving characteristics. Next, in the histogram equalization is a method in image processing of contrast adjustment using the image histogram. This method usually increases the global contrast of many images, especially when the usable data of the image is represented by close contrast values. Through this adjustment, the intensities can be better distributed on the histogram. Next, in the cluster formation, data clustering is the process of dividing data elements into classes or clusters so that items in the same classes are as similar as possible and items in different classes are as dissimilar as possible. Fuzzy clustering is a class of algorithm for cluster analysis in which allocation of data points to cluster. First, choose the number of cluster, assign randomly to each point coefficient for being in the cluster. Repeat until the algorithm has converged, that is, coefficient change between two iterations is no more than the given sensitivity threshold. Compute the centroid for each cluster using the formula above. For each point, compute its coefficient of being in the cluster using the formula above. Next, in the segmentation process, where threshold-based segmentation is used. In thresholding, pixels are allocated to categories according to the range of values in which a pixel lies. Boundaries which were obtained by thresholding the muscle fibers image. More than one threshold can be used, in which case more than two categories are produced. Thresholds can be chosen automatically. Next, in the feature extraction method, statistical features are used. That is, calculated the mean, standard deviation and variance and also median for our segmented region. Next, in the classification, neural network classifier is used. Generalization refers to the neural network producing reasonable outputs for inputs not encountered during training learning. Input-output mapping, a popular paradigm of learning called supervised learning, involves the modification of the synaptic weights of a neural network by applying a set of training samples. Further, we analyze the result as the first trimester and also the gestational age and healthy stages. Let me discuss about the running procedure for our process. Select main function.m in the current folder, right click that file and run to execute the program. Select any one images from the data set. Now the process is executing. Now I explain detail. This is the input image displayed in the figure window, and this is the background normalized image, that is subtract the background from the input image. This is the representation for filter image, which performed by HMF filter. And this is the histogram equalization image, that is enhancement of the image. This is the clustered image. So by using FCM cluster, we can cluster the image into separate region. This is the segmented image. Using threshold based segmentation, we can extract the head portion from the image. This is the representation with the images, and here I segmented the fetal head image. I subtract the fetal head image from the input image. This is the representation for lateral ventricle, system magna, and now I extracted the feature from the segmented region, that is statistical features. And this is the occipital diameter, bipetal diameter, head circumference diameter for our segmented region image. And now we obtain the result, healthy baby. And this image represent for first trimester, and this is the performance graph between existing and a proposed system for accuracy. So finally identify the fetal head portion from ultrasound image by clustering and segmentation method by using classification technique to estimate level of fetal head image.